touch anything.
So what you're seeing right now is samples of our sorbent material. You will notice that it's almost a little bit bigger than, say, sand. Or if you have silica when you buy new clothes that absorbs water, it's sort of the size of that.
Yeah, they're like perfect little spheres, kind of, it looks like.
Exactly. They're powderish almost.
So that is what is collecting the CO2. That's the material that kind of binds to it.
Exactly. So this is the material that has all the magic in it of being able to capture CO2 and enable storage.
What you're hearing here is reporter Sam Baker at a lab in Switzerland that studies how to take carbon dioxide out of the atmosphere. So often on this show, we talk about how we're changing the climate by putting more and more CO2 into the atmosphere. Today, we're going to flip the script and take a look at efforts to pull CO2 out of the air, a technology that some see as essential to addressing climate change. I'm Neil King, and this is Living Planet. Here to tell us more about this technology that promises so much is DW reporter Sam Baker.
Hi, Neil.
So, Sam, what is carbon dioxide removal? Perhaps we start there.
Sure. So on a very fundamental level, it's just taking CO2 out of the air. Plants, of course, do this naturally when they absorb CO2 and use it to grow. But the type of carbon dioxide removal we're going to talk about today is a man-made technology where machines and chemical filters capture CO2 and remove it from the air to be buried deep underground. This is often referred to as direct air capture.
Okay, sounds very technical. But you wanted to cover this topic because you've been following companies working on this technology for a while now, right?
Yeah, I got interested in this technology years ago, actually, when I was just a baby environment reporter here at Living Planet. And I found this technology really interesting and exciting. Because, I mean, how nice would it be to just have a little machine, maybe the size of an air conditioner next to your house that could suck out CO2, you know, absolving you of your carbon sins and taking out your emissions every year.
Yeah, I mean, it sounds very tempting. I'd certainly be up for that if it's affordable, that is. But I kind of also feel like, though, you know, I mean, there was a lot of talk or hype around this technology for some time, but it sort of dropped off the radar a little bit in recent years, didn't it?
Yeah, that was another reason I wanted to go back and look at this. I mean, it did get a lot of press a few years ago, including from me. You know, I interviewed a spokesperson from one of the biggest companies doing this direct air capture, Climeworks, back in 2019, about how they were capturing CO2 to be permanently stored underground. And yeah, I wanted to follow up with them to see if they've met some of their goals, like if they're on their way to removing 1 million tons of CO2 by 2030.
Just watch for the red lines.
Okay, sounds good.
We're overlooking the wet chemistry labs where we make the materials, testing facilities where we measure performance, as well as mechanical prototyping shop where we make the machine and test it for reliability.
This is Helen Cox, Chief Technology Officer at Climeworks, and she's showing me around Climeworks Innovation Center in Zurich from up above on this walkway looking down on a workshop floor.
Just to give people a sense of the space here, maybe. So this center used to be a European Space Agency where they used to build shuttles here, space rockets. So you can imagine the size, the height, and the width. So it's a very, very big space. And to me, what's most exciting is actually the speed at which we are innovating here and what the center allows. So
Helen started working for Climeworks last year, shortly before the company got some bad press.
The mammoth failure of direct air capture.
Why Swiss carbon removal startup Climeworks faces serious headwinds.
Climeworks Capture fails to cover its own emissions.
Okay, so that does sound a bit withering, but I mean, would you say this bad press, you know, is justified? I mean, after all, they are trying to do something good, right? They're trying to help solve the climate crisis with what they're doing.
Yeah, and I think we should take it with a kind of open approach and see what's really going on. So Climeworks started in 2009, raising funding and developing their machines. So they were looking for ways to sell this service of capturing and storing CO2 to companies and individuals who wanted to counteract their own emissions. So they started building a few plants in Iceland that would have many of these direct air capture machines stacked next to each other. The first was called Orca and was completed in 2021 with a capacity to capture 4,000 tons of CO2 per year. Then they built a bigger one called Mammoth, which began operations in 2024 and had a capacity to capture 36,000 tons per year. To give you an equivalent, that's like taking more than 8,000 vehicles off the road every year. But the thing is, both of these plants have never come anywhere near their capturing capacity.
Okay, so I'm guessing that goal of 1 million tons captured by 2030 is pie in the sky?
Yeah, we're talking just a couple thousand tons captured in total since opening their Mammoth plant.
Okay, so what is the problem then?
Well, basically, when these machines were deployed in the wild, they ran into all sorts of problems they didn't have in the lab. So things like changes in air temperature or humidity affecting how they functioned. And of course, these things fluctuate with the seasons or even over the course of a day. It could be cool and foggy in the morning, but hot in the afternoon. Helen told me that sulfur in the air from the geothermal plant that powered these machines also created issues. So that's what Climeworks learned in Iceland. What they'd been able to do in the lab didn't hold up out in the real world when they started to scale this up.
Okay, but that really is then more than just a wee snag, right? You know, especially if your entire business model depends on operating outdoors and in the real world, right?
Right. And if you've got investors depending on this, companies who've committed to buying carbon credits from you, that sort of thing.
Yeah.
So this takes me back to Helen at the Innovation Center in Zurich. As their new CTO, she's trying to course correct. So Helen took me downstairs where there were pipes and machines everywhere.
So if you look at here on your left-hand side, you see a big pipe coming in where the air comes in and hits that pipe where the filter material is located, then comes out on the other side. And we vary the temperatures and humidities of the air that's coming in to understand if the filter material collects the CO2 as effectively and under all kinds of different conditions.
I see. So all of these kind of boxes and then the pipes and tubes and things you have up there, that's all really to play with the air.
Exactly. So if you actually look at the capture unit there, it's a very small part of the pilot test facility. It's all about making sure we're mimicking the air to be reflective of the commercial conditions. That's really where the trick for direct air capture is.
So the other big challenge with direct air capture is that CO2 only makes up a small part of the atmosphere. It's about 430 parts per million. Now, that number has massively increased since it was 280 parts per million in pre-industrial times, and that's what's heating up our planet. But when you're sucking this stuff out of the air, it requires a lot of processing to squeeze that CO2 out from the other molecules that make up the air we breathe.
Just to give you an example, in order to capture 1 ton of CO2, you need to process about 2 million cubic meters of air. That's about 2 Empire State Buildings much. If you're walking down Manhattan and you saw 2,500 people, one of them would be the CO2 molecule. So the amount of air that we need to process through the filter material is enormous.
I mean, is this a very energy-intensive process?
It is energy intensive, so that air needs to be pulled through our capture units with fans, and that energy to pull that much air is high, right? But the really cool thing is that we've actually innovated around very low resistant materials where pulling the air through becomes much, much, much easier. We have made more than 50% improvement in cost reduction in energy consumption.
So they might be able to reduce energy costs, but the costs are still way too high for many consumers.
Can you give us a price tag there, Sam? How much are we talking?
It costs $500 per ton of CO2 removed.
Okay, I'm just guessing here now, but that sounds like it's incredibly expensive.
Yeah, so I wanted to do a little math on this and see what it would be, say, for myself offsetting my emissions for a whole year. I'm an EU resident, so the average person here emits 9 tons of CO2 per year, but I go back to the US usually once a year, so I added 2 tons for the long haul flight I take. And so let's say it's 11 tons per year, that would be $5,500. So it's doable, but pretty steep.
Okay, but I mean, they've been doing this for quite some time now, right? After a while, prices should come down normally, shouldn't they?
Yeah, you would think. So when I spoke to a Climeworks spokesperson in 2019, the cost was $600, and they were aiming to get that down to $100.
Obviously, they've really missed that target. Again, I mean, why has this been so hard to bring down? Is it just the energy costs?
Well, energy costs are one factor that, as they say, they're obviously working on. But another is that this technology just hasn't really scaled up, largely due to those problems we were talking about earlier. And a further issue is even if you've got the cash to spend on counteracting your own emissions or your company's emissions, these machines won't be delivering that carbon dioxide removal for 7 years, according to Climeworks' website.
7 years? I mean, that really doesn't sound like a technology operating at any kind of mass scale yet.
I had the same reaction, so I asked Helen about it.
That 7-year comment is to allow us to be able to manage our supply chain and delivery targets, but we have 100% record on nature-based solutions.
Okay, so nature-based solutions. It sounds a bit like corporate climate lingo to me. What does that actually mean, Sam?
Yeah, well, this is one of the things that has changed since I last spoke to them. So they are now offering customers not only what they call their technology-based solutions, so this is the removal with their machines, but also carbon credits from other projects, things like protecting forests. And we know these sorts of carbon credits often have a pretty mixed track record on how reliable they are.
Yeah. But that then also means then they've expanded into this, diversified, so to speak, to prop up what should be their core business, the mechanical way of doing things. They need the nature-based solutions to remain, well, attractive or profitable.
So, yeah, I had a lot of questions about this. And after I had gotten a tour of the facilities away from the labs and the machines, I put these questions to Helen.
I mean, we know for sure engineered solutions aren't a silver bullet. And engineered solutions today, as you rightly point out, are relatively expensive. So how do we create the market for carbon removals in general and make it big is not through engineered solutions today because the market does not absorb the current price. So if you look at the scalability of nature-based solutions versus engineered solutions basically have infinite scaling. Right? So you can basically build as many plants as we're willing to build and reduce the cost while you can only plant so many trees to be able to absorb that CO2. So we think nature-based solutions are actually quite fantastic right now because they're the price point that is absorbable by the market. But that market needs to help us get to engineered solutions so that we can scale this to an industrial scale and get to gigatons that we need to get to be able to reach our net zero targets.
Okay, let me just try and unpick that a little bit for myself to make sure I understood this correctly. On the one hand, they feel that nature-based solutions are not as scalable as engineered ones, but they're happy to go with it as long as the engineered ones are still too expensive.
Yeah, and I think a lot of questions remain about being able to scale this technology.
I think what has happened over the last 5 years or so is Climeworks has learned a tremendous amount from what it means to actually operate a commercial plant at cost targets, at production targets. I remain hopeful that we can hit $100 per ton, but I think it's quite challenging.
So Climeworks has been working on direct air capture since 2009. I know you haven't been here that long. How much CO2 is the company actually removing from the air each year?
At the moment, we don't comment on precise figures, if that's all right.
So not sure if you could hear that there, but the press officer piped in saying, we don't comment on precise figures.
Yeah, okay. But interesting that he would, interject. A company like this should be transparent about how much CO2 it's been able to capture, shouldn't it? So why the secrecy?
Yeah, you would think. I mean, he did say that Their numbers were available on a public registry of carbon dioxide removal credits. And I had done my homework before this interview, and I knew how much Climeworks had stored based on that public registry.
I do have the Puro.earth numbers here. So this is a registry that verifies CO2 removal certificates. And this was only for the past 2 years, since 2024. But Climeworks has stored 2,005 tons of CO2. The goal was 1 million tons by 2030. Does that still feel like a realistic goal, or are the goals needing to be revised?
I personally am a very ambitious person, so I would say I'm willing to do ambitious targets, but we also have to be realistic. Don't think it's possible for us to get to those levels anymore by 2030, but what I do think it's really possible by the end of this decade, which is only a few numbers of years away, I think we'll demonstrate commercially viable, profitable costs for what the market is willing to pay for CDR today, such that we can build larger and larger and larger plants over the next decade.
Okay, so, trying to be fair here, I still feel like, they're trying to solve a problem, they're trying to help. And as much as I'd like this technology to work, it does seem more like a cautionary tale right now.
There's certainly a lot to be learned from it, at least. At the same time, companies wading into direct air capture technology have actually multiplied since I started reporting on this in 2019. There are over 100 of them now.
Yeah, and there are also big international climate bodies like the Intergovernmental Panel on Climate Change. They're also banking on this to work, right?
They are. It's part of their plans towards basically taking out emissions that we've already created. So to get a better handle on all of this and understand direct air capture's role in our range of climate solutions, I spoke with Carl Greenfield, an analyst at the International Energy Agency who specializes in carbon dioxide removal.
I think I would say that the main message is that carbon dioxide removal, it's not a substitute for cutting emissions. We need both. We need to cut our emissions and remove emissions. So if you think of our atmosphere like a bathtub, right now the tap, our emissions is still running. And the first and most important step is to turn down, or ideally turn off, that tap as fast as we can. So that's cutting emissions. But even if we manage to slow this flow, the bathtub is already still quite full. And what DAC does is it helps with that second job of pulling the plug and helping that water drain out. So the key point is that we need both of these. We need to turn off that tap, we need to reduce our emissions, and we need to remove some of those emissions that are still within the atmosphere.
Yeah, and when I think about this, I often think of the historical emissions that countries and companies have put into the atmosphere as well. To my knowledge, no one's taken care of their historical emissions yet because they're just trying to get their current emissions out. But have you heard that talked about in the industry? Or is that something more that countries will have to do towards their climate goals?
I think we'll be having this conversation probably in the next decade or couple of decades, as right now a lot of the focus is on the emissions reduction side, and getting these removal technologies to scale is really at the questions that you're asking. How much will it cost? Who's going to lead it? Where is it going to be deployed? How this will impact the larger emissions reduction or removal strategy of a country, I think it's still open to see how countries and companies plan to use this.
You just mentioned the historic emissions there, Sam. Basically, those are the emissions that are already in the atmosphere, because CO2 does linger for a while, right? And eventually we have to get rid of this stuff as well, because the bathtub, the analogy there is very accurate, right? It just fills up.
Yeah, and some climate scientists I've talked to have even talked about overshooting 1.5 degrees, and that we'll have to then try and kind of come back down from that. So that would require taking CO2 and other greenhouse gases out of the air.
Yeah. So, I mean, if global climate plans are counting on this, but the technology hasn't really proved itself at scale yet, it does feel like a pretty big gamble. Are we betting on the wrong horse here?
Well, here's what Carl had to say.
If we look at the IPCC 1.5 degree scenarios, there's a substantial reliance on carbon dioxide removal at anywhere of, I think it's an average of 12 billion tons by 2100. So it's a massive scale up from what we have today. In terms of what that means for the overall slice of the pie, it depends on how much action is done today. But if you include CCS as well as direct air capture and some of the other removal technologies, we expect that to be around 6% of emissions reduction by 2050. So not a small amount, but it's much smaller than, say, electrification or renewables plays in the overall picture.
Okay, so sorry, he had a few acronyms there. So DAC is direct air capture and CCS is carbon capture and storage, where you capture CO2 before it's emitted and then store it underground.
There is one other area where carbon dioxide removal might prove profitable and might be very promising. And we're going to have more on that after this break.
When headlines get louder, we go deeper.
Say hello to Berlin Briefing,
Your guide to Germany's impact on the world. Between East and West, autocrats and democrats, Germany's whole system is under stress.
pressure from all sides.
And the world around Germany is getting more dangerous.
Is democracy glitching? Too much noise? Too little clarity?
We decode what it means for you. From Berlin to right where you are.
It's all in Berlin Briefing on YouTube and wherever you get your podcasts.
Welcome back. This is Living Planet with me, Neil King, and with me in the studio is our reporter and producer, Sam Baker. And Sam, in the first half of this episode, we talked a lot about the company Climeworks and some of the snags that they've encountered in scaling their direct air capture operations. And the bottom line there was that it's still, well, let's say quite a way off from reaching the scale that we'd need for it to have a noticeable impact on the climate. I think it's fair to say that. But you also visited another company that is taking a slightly different and, daring approach, right?
I did. I took a short trip not very far from our studios here in Bonn to see another direct air capture process up close.
You can really see in here the carbon being collected. I'm kind of surprised. I mean, there's like these little white crystal-y chunks, as well as some liquid coming down the outside.
Correct. And this is a new process innovation, but essentially it's all happening inside the column.
So remember how I said there were over 100 direct air capture companies now filtering CO2 out of the air like Climeworks? Well, I wanted to see what some of the newer companies in this space are up to and where they might be headed. So I drove to a part of Germany once known for its coal and steel production. Now it's home to the direct air capture company Greenlight. And in a parking lot in Essen, their CEO and co-founder Florian Hildebrand showed me how they're capturing CO2.
We are now in front of the absorption column, which is where our process starts. We see a big vertical column, a fan on top, which sucks in air through these black filters. And then the solution flows down the column. And as air gets in contact with the solution, the CO2, which is very dilute in the atmosphere, is sort of sucked into the liquid and reacts. And over time, more and more white powder piles up. Eventually, we have this white slurry, which is then going into sort of a buffer tank. And on the other side, we have the back-end unit in this green container where we then release the CO2 again.
So not a terribly different process than what other companies are doing. But what makes Greenlight different is what they want to do with the CO2 after they've captured it. Instead of storing it permanently, Greenlight is capturing CO2 to sell to companies making things like sustainable aviation fuel or e-methanol for shipping.
So we give them either green CO2 and green hydrogen and green oxygen, or we give them green CO, which is carbon monoxide or green hydrogen. But essentially, we just give them the pure molecules, the pure product.
Wow, I'd never heard of this before. Sam.
Did you even know there was a market for such a thing?
I had no idea. And I'm still having a little bit of trouble getting my head around it. Because let me just rephrase it again, what he just said. That they're essentially capturing CO2 and repurposing it so that it can be used to fly airplanes, for example.
Yes. And it took me a second to get my head around this equation as well. But basically, this is a carbon neutral process because they're taking that CO2 out of the air, but then they're re-emitting it. So there's no additional CO2 going into the air.
Okay.
Does that make sense?
I think it does. I think I've got it now. So it's It doesn't solve the historic emissions, right?
No, it doesn't solve historic emissions at all.
It just stops things from getting worse.
Exactly.
Okay. Yeah, but still, I mean, it's worth investing in that technology as well, I guess, if it's scalable, right?
Yeah. And I mean, when it comes to things like aviation fuel or shipping, these sorts of fuels are hard to replace.
Okay. So, Sam, again, bottom line, just, how profitable and scalable is this?
So I think the difference between this and Climeworks is depending on companies or individuals just having the goodwill to choose to voluntarily take their emissions out of the air and pay for that. This process, however, is selling a product to companies who want these more sustainable fuels. Now, that might still rely on regulations for things like sustainable aviation fuel and e-methanol. But as we're seeing with different geopolitical developments in the world, this might be something these companies want to buy regardless of their environmental concerns.
There's another angle to it, which is the resilience angle. And that's what we're doing together with Rheinmetall, Ineratec and Sunfire and a few others, is to build small-scale off-grid fuel productions in Europe to essentially provide fuels into defense equipment, where you're not dependent on Russian or oil now coming from the Middle East, which is obviously blocked because of the Strait of Hormuz.
I mean, with all that's been going on with airlines responding to the fuel crisis lately, Lufthansa and Germany cancelling lots of flights. So maybe this, what Florian mentioned, this could help, right?
Yeah. And actually, they're even working with Lufthansa and its subsidiary Eurowings to supply this feedstock for sustainable aviation fuel. And they're doing that for about 60 flights between Mallorca in Spain and Dusseldorf here in Germany.
Okay. Well, it's a start, I guess, right?
Absolutely, yeah.
But I mean, without putting too much stock on what startups say, about their own
Sure.
business, where does Florian see this going?
So he thinks that because of this energy independence, as well as the environmental angle, that companies are willing to buy these products.
It's not like a nuclear power plant, which needs 15 years of building with many components. Ours is quite simple. Technically, it, maybe not just like solar, but a little bit like wind energy, where it should just scale over time and it should be simple enough to build anywhere.
So, Sam, now, the question I've been asking myself all along is this a technology we should be investing more in? Or is it something where we say, okay, if it's about, saving the climate, it's not worth pursuing this anymore, we should pull the plug now and the money's better spent elsewhere?
I think what these examples show are a couple things. First of all, there needs to be a business case there really driving this, because there isn't regulation driving the need for this yet. From a few of the experts I spoke to, the reality is that the investments in carbon dioxide removal are pretty small compared to, say, investments in renewables. So I think we have to kind of put that in context as well. But I would say one big conclusion is we should not be depending on this to absolve us of those climate sins, of fixing climate change. And I think these companies would tell you that themselves, too. So it shouldn't be looked at as a big climate solution. It should be looked at as a very small piece of many other solutions that we're going to need to get there.
Next week, Sam, you're with us again, taking us to Norway, where a project led by a bunch of fossil fuel companies and the Norwegian government is burying much larger amounts of CO2 under the North Sea. And they've even got a faithful companion to help in the endeavour.
Oh my gosh. That is a robot dog. You were not joking.
No, I was not. We are testing out a robotic dog for inspection.
He can sniff CO2.
Yeah.
Wow, that is so crazy.
You really won't want to miss that. Today's show was mixed by Michael Springer, reported by Sam Baker, and hosted by me, Neil King. Thanks for joining us. See you next week.